Hello everyone, we are the students of Shivajirao S. Jondhle College of Pharmacy, Asangaon. We presenting synthesis of Coumarin by green method under the guidance of Mrs. Manjusha Sarnap, Assistant Professor, Department of Pharmaceutical Chemistry. I am Namrata Menon and my coordinators are Gaurav, Naik and Mansi, Mhatre. Contents: Introduction to Coumarin, Introduction to Green Chemistry, Method to Preparation, General Procedures, Scheme of Synthesis, Calculation, IR spectrum and references. Introduction to Coumarin. Compounds containing coumarin backbone are a very important group of compounds due to their usage in pharmacy and medicine for development of new drugs. Therefore, many different methods and techniques are developed in order to synthesize coumarin derivatives. Coumarin derivatives could be obtained from different starting materials with various methods but with big differences in yield. This review summarized green methods, techniques, and reaction conditions. Green method is process that reduce or eliminate the use or generation of hazardous substances. We use different green catalysts for the synthesis. Coumarin or 2H-chromane 2,1 is an aromatic organic chemical compound. Its molecule can be described as a benzene molecule with two adjacent hydrogen atoms replaced by a lactone-like chain. The chain is given as follows, forming a second six-membered heterocycle that shares two carbons with the benzene ring. Figure 1 shows structure of coumarin. Green chemistry. What is green chemistry? Green chemistry is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. Green chemistry applies across the life cycle of a chemical product, including its design, manufacture, use, and ultimate disposal. Green chemistry is also known as sustainable chemistry. Objectives of green chemistry are prevents pollution at a molecular level, is a philosophy that applies to all areas of chemistry, not a single discipline of chemistry, applies innovative scientific solutions to real world environmental problems, results in source reduction because it prevents the generation of pollution, reduces the negative impacts of chemical products and processes on human health and the environment, lessens and sometimes eliminates hazard from existing products and processes, designs chemical products and processes to reduce their intrinsic hazards. The next slide would be explaining by my coordinator, Miss Mansi Mhatre. Thank you.
General procedures for the synthesis of coumarin by green chemistry methods. 1.1 gram of resorcinol was dissolved completely in 1.35 gram of ethyl acetoacetate in a 50 ml dry round bottom flask. K10 Montmorillonite clay, which is 1.5 gram, was added to this homogeneous mixture and mixed thoroughly using glass rod. The reaction mixture finally appeared as a paste. It was then placed on a hot water bath and heated gently for 3 to 4 hours. After the completion of reaction, mixture was cooled to the room temperature and 7-hydroxy-4-methyl coumarin was extracted with ether by vigorous shaking. The clay was separated by filtration through Whatman 4 filter paper. This separation with ether was repeated for 2 times. Finally, the filter was evaporated and the product is obtained as a white solid. General procedures for the Pechmann reactions. First is ultrasound method. A mixture of appropriate phenol, beta-ketoester and anhydrous FeCl3 was placed in a 10 ml glass tube and was sonicated for 1 to 20 minutes until the completion of reaction checked by TLC. The tube during sonication was immersed in a cooling bath set at 20 degrees Celsius. For compounds, the reaction mixture solidified upon the completion of the reaction due to the product precipitation. Subsequently, ethanol was added, which is ultimately 5 ml, and the product crystallized upon dropwise addition of water. The solid was filtered, washed with water, and was recrystallized from ethanol or water. The final product was then dried under the high vacuum over phosphorus pentoxide. Second method is microwave method. A mixture of appropriate phenol, beta-ketal ester and anhydrous FeCl3 were added to the thick-walled borosilicate glass tube 10 ml. The tube was sealed and was placed in a CEM Discover lab-made microwave reactor and was irradiated 100 degrees Celsius for 10 minutes. After cooling to room temperature, 5 ml ethanol was added and the product recrystallized upon dropwise addition of 15 ml water. This solid was filtered, washed with water and was recrystallized from ethanol or water. The final product was then dried under the high vacuum over phosphorus pentoxide. The next slide will be explained by Gaurav Naik.
Calculation of percentage purity of coumarin. 1 mole of resorcinol is equal to 110.1 gram of, and 1 mole of 7-hydroxy-4-methyl coumarin is 176.17 gram. So by cross multiplying, we get the theoretical value, that is 1.76 gram. So theoretical yield is 1.76 gram and our practical yield is 1.1 gram. Therefore, percentage yield can be calculated by practical yield upon theoretical yield into 100, which gives 62.5% yield. Infrared spectroscopy is the measurement of the interaction of infrared radiation with the matter by absorption, emission or reflection. It is used to study and identify chemical substance or functional groups in solid, liquid or gaseous form. Structure of coumarin consists an aromatic ring, a carbonyl group, a alkyne group, an hydroxy group and a COC bond. Here the aromatic ring can be identified by peak number 7, 8 and 9, as the aromatic ring ranges between 1600 to 1500 to 1430, and peak number 7 shows 1599.66 range, peak number 8 shows 1520.6 and peak number 9 shows 1448.28. So we can predict the presence of aromatic ring. Peak number 6 shows the presence of carbonyl group. The range is 1665.23 and the range of carbonyl group is 1780 to 1650. While peak number 5 shows presence of alkyne bond. The range is 2237.99 and the range of alkyne bond is 2100 to 2250. Presence of hydroxy group, that is OH bond, can be identified by the peak 1 and 2. The reading is 3487.63 and 3431.71 and the range between which OH group is identified is 3400 to 3700. Peak number 13, which has reading 1146.47, shows the presence of COC bond whose range is 1200 to 1180. These are some references which we used to study the synthesis of coumarin. We would like to thank our President Dr. Shivajirao Jondhle, Dr. Gare and our Principal, respected Dr. Nitin C. Mhatre, for giving us this opportunity.